Welcome to this presentation on rendering user interface using trees. There are two fundamental principles of interaction programming. One is that most graphical user interfaces are represented internally as trees. The other principle is that user interaction is detected by subscribing to events on the nodes of this tree, such as subscribing to clicks on button nodes, and so on. All technologies used in the course have adhered to these principles. In the current lab, we use JSX and hyperscript for DOM rendering with React and Vue frameworks. Also interesting are these non-graphical libraries for managing interactive application state. You can work with any of them in advanced labs for bonus points. In this presentation, we will be focusing on the first principle, the trees. Most of the notions introduced here are valid in interaction programming in general or have a correspondent in other UI technologies. The most important ones, such as the trees, have a gray background. Here is how this graphical user interface would be represented as a tree in most user interface technologies, and how this tree would look like in a web browser. The tree nodes in all caps represent interactive HTML widgets and are called elements. They can be configured via attributes. For example, here we configured borders using the style attribute. In blue, we show texts that are part of the tree and have no children. Those are called nodes. The API which lets us manipulate the browser tree is called the Document Object Model, or DOM. There is a one-to-one correspondence between the DOM tree and its associated HTML, but in modern single-page application programming, HTML files are rarely used to describe user interface. Instead, everything is rendered in JavaScript. A brief description of the HTML elements used here. Divs usually have no graphical appearance but are used to graphically organize their child nodes. Divs usually take all the width available to them. They are like paragraphs. Spans, but also text nodes and buttons and many other HTML elements behave like words in a paragraph, taking only the horizontal space needed and flowing to the next line if they fill up to the end of the row. Here we have the rendering code of the upper panel using basic DOM APIs. A minimal set of methods for creating elements and nodes are create element with a type of node, set attribute, name and value, appending a child element, or appending just a text node. We can see that the code for rendering user interface with such basic APIs is hard to write and maintain, with lots of interdependent variables, for example. Instead, using the basic DOM methods, we can easily write a function that takes three parameters: the element type, the element attributes, and any number of children. Here we have a div being created with some attributes and three children being added, two buttons and the number between them. Here we have a simple HTML file where we have loaded the hyperscript implementation made for the course. Now we can use the h function, the hyperscript function, in the console. Here we make a div with a border. It is not visible, it is in memory, not in the page. In order to show it in the page, we have to add it to the document body. We do that using the append function, which we have already introduced. And we copy here our. Now we have added to the page an empty div with a border. in order to show a bit more in it, we need to add something in the div. And we can add, for example, a button. With no attributes and maybe a minus label. We have added it, by the way, after the previous one. So now we have reloaded and we see the button in the browser. The HTML file has of course not changed, but if we look in the elements here, we can see our div and our button. And we can go on like that. We reload, everything disappears. We add another button with a plus label. And then we see our div here with the two buttons, and we can continue adding after a reload also our number in between the two. And now it's going to be just a constant, but we will make it better later on. So this is the interface we are after, and we can see it having developed here in the Elements tab. The other thing we can do is in these very powerful developer tools is actually to add a debugger command. And now our code has stopped, and we can make, for example, if we don't know how this one is rendered, we just put a breakpoint here and we run the code, and our code stops here, and we can investigate this particular button. There are many hyperscript implementations out there, but we will work with three: React Create Element, Vue H, and the simple implementation written for the course. It was written to illustrate how hyperscript can be implemented with simple DOM APIs. One interesting feature of hyperscript is that it is easy to define entities that appear like new HTML elements. They are called custom components and can be implemented, for example, as functions with a single parameter, which we usually refer to as props, short for properties. With the component thus defined, we can use it in the same way as an ordinary DOM element, but with props instead of attributes. Here you can see several equivalent forms of this code using the object destructuring, which lets us use the prop name directly rather than having to write props number, or a thick arrow function, or even shorter, a thick arrow function that simply returns a hyperscript and doesn't have to have the return keyword and the curly braces. JSX was designed for generating hyperscript with a more intuitive syntax. JSX translation to hyperscript is achieved using a transpiler like Babel. With JSX, custom components look even more like new HTML tags. However, JSX is translated to a JavaScript expression. It is not at all HTML. You can also see this trailing slash required by well-formatted XML, but not by HTML. Also, unlike HTML, JSX can easily insert JavaScript expressions in curly braces, shown in orange here. Even if it isn't pure JavaScript and it can't be used in the browser, at least not in the browser JavaScript console, JSX can be debugged in the developer tools. Here we have a simple HTML file where we have loaded our course hyperscript and Babel. We have an empty body and we have a script of type text.jsx, which is Babel's cue to start converting from JSX to hyperscript, basically. We have also in the script added to the document body our number editor custom component, which almost looks like a new HTML element. If we look at the elements of this interface, we can find here our component having been rendered, but we also see a new script here which we don't have in the original HTML. And in this new script, Babel has actually translated from JSX to hyperscript. And it has also put in here this string, which is actually a source mapping. And the source mapping helps us, if we click on this inline Babel script source here, we see here the JSX source, and it allows us to debug in this source. So if we reload now, our code will stop here and we will be able to see, for example, the value of this number prop here. Rendering a user interface subtree just some of the times and sometimes not, depending on a condition, is a very frequent task in interaction programming. Since hyperscript and JSX are JavaScript expression, they can be combined with JavaScript Boolean variables and other expression using logical operators like this ternary operator here, or and, or. The result of such expression can be either a hyperscript tree to be rendered, or it can be a false value to indicate that nothing should be rendered. Rendering repetitive user interface, for example to represent array data in lists or tables, is another frequent task. The array map higher order function calls a given function for every element of an array and collects the results to the result array. We can use the array map to turn an array of abstract objects like this dish data into an array of user interface DOM subtrees. We can pass this array as a third parameter to a hyperscript function of a container element, such as the unordered list here. Hyperscript and JSX will in the end render DOM objects, which, like all JavaScript objects, contain properties. The attributes that we set in hyperscript or JSX are used to initialize these three node properties. For example, this input element initialized with size and value attributes will have properties like these, where we list a subset of its properties. Read-only properties are usually related to the tree structure, for example, parent element, first child, next sibling, or previous sibling. Writable properties like value for an input box or node value for a text node can be changed with immediate effect in the browser. This could be used to update the user interface, but in modern interaction programming, components are often re-rendered rather than updated, so our code is working with attributes most of the time. So here are the main concepts introduced in this presentation. Some concepts you will not use directly, but it's good to know about them and use them when needed. Hyperscript, JSX, attributes, and custom components you will use frequently in the lab and in project. We also try to illustrate how these more advanced concepts are implemented using the basic DOM concepts introduced. Thanks for watching.